Hi guys, so today we're going to look at something called completing the square. And for your essential question, you need to describe the process of completing the square. Now, before we get to our guided practice problems, the first thing I want to recall is the perfect square trinomial special pattern when it comes to factoring. So we know the perfect square trinomial is f squared plus 2 times f times g plus g squared. And then we know that this factors to give us a binomial squared every single time. So this comes from our 3.4 lesson. So if this is not familiar to you, please make sure you look back at that 3.4 lesson. So if we were to go through the process of using the x to factor this, recall that it factors to give us f plus g squared. So in our perfect square trinomial, we know that the first term is a perfect square. We know that the last term is a perfect square. And then we know that the middle term is derived by multiplying 2 times this number's square root times this number's square root. So we're going to apply that to what we're going to see today. So for our first guided practice, we need to go through and decide what number has to be added to this polynomial in order to complete the square. So again, what we're looking to do is create that perfect square trinomial, f squared plus 2 times f times g plus g squared. So we have the f squared term here, that would be x squared. We have the 2 times f times g squared, which is 8x. And then this term here is derived by taking g and raising it to the second power, so g squared. So we have to figure out the value of g in order to fill in this blank here. So again, we know that x squared is f squared, which means that f in this case would be x. Then we know that 8x is equal to our middle term, which is 2 times f times g. So we can say that 2 times f times g is equal to 8x. So if we wanted to solve for g, we could maybe do some finagling here. Well, again, remember that f is in place of x, or x is in place of f when it comes to the special pattern. So we can take that x and we can substitute it here for f. So instead of 2 times f times g, we could say 2 times x times g is equal to 8x. And in an effort to solve for g, we could now go through here to get g by itself, divide both sides by 2x, and we get g is equal to 4. So our g value, for the sake of the special cases, is 4. And 4 squared gives us 16. So this now is a perfect square trinomial that fits this pattern here. So let's take a look at another one. So in order for us to complete the square, we have to figure out the value of g. We know that this is x squared, so we know that x is our f term. And we know that negative 22x is equal to our middle term, so 2 times f times g is equal to negative 22x. We know that we can replace the f with x. So 2 times x times g is equal to negative 22x. Divide both sides by 2x, excuse me. And g is equal to negative 11. So negative 11 squared is what will fill in this blank. So we fill in this blank with 121. All right, let's look at another one. Here we have x squared, which is in place of the f. So we know that f is x. Just have to find that g value. So we know that 16x is equal to 2 times f times g. We know that x is equal to f, so 2xg is equal to 16x. We can divide both sides by 2x, and g is equal to 8. Plug that in here, and g squared, 8 squared, gives us the blank, so this is going to be 64. Now, our whole goal here is to be able to get to a point where we can rewrite our polynomial as a binomial squared. So we're looking to put it in factored form. That's what we're working towards. And so if you recall, when we're factoring, our first step is to always factor out a GCF, right? And so here, I realize that they're both divisible by 3 and x, but we're looking to fill this in. So we don't want to take that x away. But we do want to go ahead and divide out that a value in order for us to complete the square, because 3x is not a perfect square. So we're going to divide out that 3, and that's going to leave us with x squared minus 8x. And then we're going to fill in the blank to complete the square here. So as a toolbox item, I will say that anytime your a value is not positive 1, you need to divide that number out. So here we're dividing out 3. If it was 2, you would divide out 2. If it was a negative, you would divide out a negative 1. Anytime it's not positive 1, you're going to divide that number out. So here, to find this blank value, we're going to set 2fg equal to negative 8x. We know that x is our f value, so we can replace that with x. We divide to get g by itself, and we get g is equal to negative 4. So to fill in that blank, we take g, negative 4, and we square it, and that gives us a value of 16 here. Now, if we were to work backwards so that we could fill in the blank from the original polynomial, we factored out that 3, remember? So if we're going to go back to standard form, we would redistribute that 3, giving us 3x squared minus 24x plus 48 would be that full polynomial in standard form. All right, so this is finding the number to be added in order to complete the square. From here, we're going to take it a step further and rewrite it in factored form, so as binomials squared. So for GP number 2, we are now rewriting each polynomial as the square of a binomial. So our answer needs to be some binomial squared. So basically, we're taking this and we're factoring it. But keep in mind that all of the polynomials that we're going to see, this is the same polynomial that we dealt with GP number 1a. All of these polynomials are, in fact, perfect square trinomials because we created them to be perfect square trinomials. So now we know that when we have a perfect square trinomial, f squared plus 2fg plus g squared, this will always factor to give us f plus g squared. So as long as we can still identify that f value and that g value, we can then plug those numbers in to create this binomial squared. So remember, this was the term in place of the f, this was the term in place of the g. So our perfect squared, or I'm sorry, our binomial squared is going to be f, which is x, plus g, which is 4 to the second power. So we have x plus 4 squared. So same thing here with this one. This is going to factor to give us a binomial squared, or the square of a binomial. Our f value from here is x, and our g value from here is negative 11. We also know that anytime our b value is negative, that's going to create a negative within our binomial, and so that's going to give us x minus 11 squared as the square of a binomial for this perfect square trinomial that we created in GP number 1. And again, for this one, our f term is x, our g term is 8. It's a positive 8, our b value is being added, so this is x plus 8 squared. And then lastly, for this one here, we factor just the trinomial into the binomial squared. So f is x and g is a 4, not a positive 4, but a negative 4 squared. And then that GCF that we took out always appears at the beginning of the binomial. Now notice that this is starting to look a whole lot like our text form here. So moving into day 2's lesson, this is what we're going to be using completing the square to do for us.